thermostat wires for an air conditioning unit are considered Class 2 wiring as per the National Electrical Code, specifically the 2008 edition in this case. Class 2 circuits are defined as circuits that are powered by a source that has a maximum output voltage of 60 volts root mean square or less, and a maximum output current of 5 amps or less. The National Electrical Code Article 725 addresses Class 2 wiring and its installation requirements. Article 725 provides guidelines on how Class 2 wiring should be handled to ensure safety and prevent interference with other electrical systems. Specifically, it covers topics such as wiring methods, overcurrent protection, and separation from other types of circuits. One key consideration is whether Class 2 wiring is permitted to be installed in the same conduit as power conductors. According to the National Electrical Code, Class 2 wiring is permitted to be installed in the same conduit as power conductors, provided that the Class 2 wiring is installed in a separate compartment within the conduit. This means that there must be a physical barrier or separation between the Class 2 wiring and the power conductors to prevent any potential electrical hazards or interference. Alternatively, Class 2 wiring can also be installed in a separate conduit altogether. This approach provides the most complete separation between the Class 2 wiring and the power conductors, minimizing the risk of any issues arising from their proximity. In the described situation, if the air conditioning company is running the thermostat wires in the same conduit as the power conductors without using a separate compartment, then it would indeed be a code violation. This is because it violates the National Electrical Code's requirement for separation between Class 2 wiring and power conductors when they are installed in the same conduit. The purpose of this requirement is to protect the Class 2 wiring from potential damage or interference from the power conductors, as well as to prevent any safety hazards that could arise from their interaction. Therefore, it is important for the air conditioning company to ensure that they are following the National Electrical Code's guidelines when installing thermostat wires in the same conduit as power conductors. This can be achieved by either using a separate compartment within the conduit to separate the Class 2 wiring from the power conductors, or by installing the Class 2 wiring in a separate conduit altogether. By adhering to these guidelines, the air conditioning company can ensure that their installations are safe, compliant, and in accordance with the National Electrical Code. Now let's delve deeper into the specific aspects of Class 2 circuits, National Electrical Code Article 725, and related wiring practices. Firstly, it is important to understand the fundamental characteristics of Class 2 circuits. As mentioned earlier, Class 2 circuits are characterized by their limited voltage and current levels. The maximum voltage for a Class 2 circuit is 60 volts root mean square or less, and the maximum current is 5 amps or less. These limitations are put in place to minimize the risk of electrical shock and fire hazards. Class 2 circuits are commonly used for low-power applications such as thermostat controls, doorbells, and low-voltage lighting systems. Because of their low-power nature, Class 2 circuits are generally considered to be safer than higher voltage and current circuits. Secondly, National Electrical Code Article 725 provides detailed requirements for the installation and wiring of Class 2 circuits. This article covers a wide range of topics, including wiring methods, overcurrent protection, and separation from other types of circuits. One of the key provisions of National Electrical Code Article 725 is the requirement for separation between Class 2 wiring and power conductors. As previously mentioned, Class 2 wiring is permitted to be installed in the same conduit as power conductors, but only if certain conditions are met. Specifically, the Class 2 wiring must be installed in a separate compartment within the conduit. This separate compartment can be achieved by using a physical barrier or divider to isolate the Class 2 wiring from the power conductors. Alternatively, the Class 2 wiring can be installed in a separate conduit altogether. The purpose of this separation requirement is to prevent any potential electrical hazards or interference that could arise from the proximity of Class 2 wiring and power conductors. Power conductors typically carry higher voltages and currents than Class 2 wiring, and their electromagnetic fields can potentially induce voltages or currents in the Class 2 wiring. This could lead to malfunction or damage of the Class 2 circuit, as well as potential safety hazards. Therefore, it is essential to maintain adequate separation between Class 2 wiring and power conductors to minimize these risks. Thirdly, let's consider some practical implications of these requirements. In the specific scenario described, the air conditioning company is running thermostat wires in the same conduit as the power conductors without using a separate compartment. This practice is a violation of the National Electrical Code because it does not meet the separation requirements outlined in Article 725. To rectify this situation, the air conditioning company has two options. The first option is to install a separate compartment within the conduit to isolate the thermostat wires from the power conductors. This can be achieved by using a divider or barrier that physically separates the two types of wiring. The divider or barrier should be made of a non-conductive material to prevent any electrical conduction between the thermostat wires and the power conductors. The second option is to install the thermostat wires in a separate conduit altogether. This provides the most complete separation between the thermostat wires and the power conductors, minimizing the risk of any potential issues. When installing the thermostat wires in a separate conduit, it is important to follow all applicable National Electrical Code requirements for conduit installation, including proper sizing, support, and grounding. Furthermore, it is crucial to ensure that the thermostat wires are properly insulated and protected from physical damage. Thermostat wires are typically low-voltage wires, but they can still pose a risk of electrical shock if their insulation is damaged or compromised. Therefore, it is important to handle thermostat wires with care and to use appropriate wiring methods to ensure their safety and reliability. In addition to the above considerations, it is also worth noting that some local jurisdictions may have additional requirements or interpretations of the National Electrical Code regarding Class 2 wiring and its installation. Therefore, it is always advisable to consult with local electrical inspectors or authorities to ensure compliance with all applicable regulations. By following these guidelines and best practices, the air conditioning company can ensure that the thermostat wiring installations are safe, compliant, and in accordance with the National Electrical Code. This will help to prevent electrical hazards, protect the integrity of the thermostat circuits, and ensure the long-term reliability of the air conditioning system. Now, let's discuss some of the reasons why it's important to adhere to the National Electrical Code requirements for Class 2 wiring. Firstly, safety is paramount. The National Electrical Code is designed to protect people and property from electrical hazards. By following the National Electrical Code requirements for Class 2 wiring, you can reduce the risk of electrical shock, fire, and other potential dangers. Secondly, compliance is essential. The National Electrical Code is adopted by many local jurisdictions as the basis for their electrical codes. Failure to comply with the National Electrical Code can result in fines, penalties, and even legal action. Thirdly, reliability is important. Proper installation of Class 2 wiring can help to ensure the reliable operation of thermostat circuits and other low-voltage systems. By following the National Electrical Code requirements, you can minimize the risk of malfunctions, damage, and other problems. In addition to the above reasons, it's also worth noting that the National Electrical Code is constantly evolving to keep pace with new technologies and changing electrical practices. Therefore, it's important to stay up to date with the latest National Electrical Code requirements to ensure that your electrical installations are safe, compliant, and reliable. To summarize, the thermostat wires for an air conditioning unit are typically considered Class 2 wiring as per the National Electrical Code. Class 2 circuits have specific voltage and current limitations to minimize the risk of electrical hazards. National Electrical Code Article 725 provides detailed requirements for the installation and wiring of Class 2 circuits, including separation from power conductors. Running thermostat wires in the same conduit as power conductors without proper separation is a violation of the National Electrical Code. To comply with the National Electrical Code, the air conditioning company should either install a separate compartment within the conduit to isolate the thermostat wires from the power conductors, or install the thermostat wires in a separate conduit altogether. By following these guidelines and best practices, the air conditioning company can ensure that their thermostat wiring installations are safe, compliant, and in accordance with the National Electrical Code. Furthermore, it's important to stay up to date with the latest National Electrical Code requirements and to consult with local electrical inspectors or authorities to ensure compliance with all applicable regulations. This will help to protect people and property from electrical hazards, ensure the reliable operation of thermostat circuits, and avoid any potential fines or penalties.